Okay, we are back on track. I hope you all enjoyed your lunch. So we will continue with a talk about Linux tuning for databases with Colin Charles.
Thank you. Good afternoon. I'm guessing all of you run Linux in production? Yes? No? FreeBSD. Okay, so there are obviously some things that change for FreeBSD that are not quite Linux-centric, but hopefully you'll also still learn some things from the talk. Do all of you run databases? Yes? Yes, okay. Maybe MySQL ecosystem databases? Okay. Postgres? Okay. Hbase, Hadoop ecosystem, Mongo, Redis, React. Anything else I didn't mention? Oracle, oh yeah. So they make an operating system and processors for your Oracle database. You can buy an Exadata. Okay, so I'm going to focus on open source databases in this talk. I'm Colin. I work on MariaDB server, and I've been in the MySQL world for quite some time, doing MySQL before and also Fedora and OpenOffice. This is my rough agenda for what we plan to cover today. How many here are actually using some kind of cloud provider, be it Amazon or Rackspace? Or... Okay, so most of you are still running bare metal in data centers. Excellent. Yeah, I'm going to talk to you about I/O, file systems, and a lot of this is obviously, most of this is Linux specific and not BSD related. So, obviously the focus of the talk is Linux. And I'm sure if you've been a Linux user for a long time, you also realize that all Linux distributions make a difference. Things are different in the Debian world. How many here use a Debian-based system? Okay, how many people here use an RPM-based system? Most of the rest of you, okay. So you will see that even versions of Linux distributions tend to change things. While RHEL 5 is still in support, though very limited support, or CentOS 5, so to speak, you can also, obviously use Ktune. And Ktune, TuneD, as well as the TuneD that you see inside of RHEL 7, it's all about tuning profiles. And you can achieve this in Debian as well by tuning things like kernel scheduling granularities. You can also change the scheduler yourself. You can also, play with the VM dirty ratios yourself. And you can do things like, set VM dirty background ratio to start flushing to disk, as well as VM dirty ratio in general, which obviously requires you to have synchronous I/O operations. And this can all be given to you via monitoring things like proc vmstat. So having some kind of monitoring in place for Linux is extremely important to know how to get the most out of your OS. And of course, if you happen to use CentOS or RHEL, it becomes a little easier thanks to just having these preset profiles that you can use and get away with. Throughput performance on CentOS 7 seems to work pretty well for most database servers, even if you happen to be running this database server inside of EC2. So, since many of you are doing bare metal stuff, it's probably worth thinking that, do you think about CPU, memory, and then I/O? Database servers are obviously very much more I/O bound than you would think, and they require a lot more I/O capacity than memory and then only CPU. But it turns out that today you can buy devices that can give you lots and lots of I/O, like a Fusion I/O device that can give you 120,000 I/O per second. And then you'll find that your database actually cannot use all that I/O. So MySQL In the earlier days, would maybe top out at 40,000 I/O per second, and this has obviously improved over time. And the way to work around this is, of course, to start up multiple instances and then make use of all your I/O. So we've reached a stage where I/O is important, and you can now afford to get I/O that actually outperforms your database. But obviously, the next thing is memory. That's also fairly important. If you use something like Amazon, you also are able to get something known as provisioned IOPS or PIOPS. And that gives you provisioned IOPS for up to 3 terabytes of storage, and they will guarantee you that per database instance will get up to 30,000 IOPS, and this is depending on how much you'd like to pay as well. Now, when it comes to things like queries, and you're doing scans of large tables, or even index scans, or even doing changes to a row, you will realize that changing sometimes even 256 bytes in the row may actually call up an update of up to 8 kilobytes in page size. And this can actually be fairly suboptimal for you. And depending on the kind of data, you can now tune your InnoDB page sizes. Previously, you'd only have 16 kilobytes, but with MySQL 5.7 and MariaDB 10.1, you can tune this to basically go up to 64 kilobyte pages. And the page sizes that you're using for InnoDB should also probably match sizes that you're using on your file system. Generally speaking, if you happen to be using this on something like EC2, where you really, that's the only one, Amazon is the only one that gives you PIOPS, we find that provisioned IOPS is much better than raiding things yourself, because you can take your provisioned IOPS up and down dynamically, thus helping you save money. The other thing that's probably important to remember is you always want to be durable. When you're buying servers, you tend to buy battery back RAID storage. And today you can run your MySQL in a fully durable mode, which basically means that after every transaction commit, you should actually call fsync. But fsync calls on Linux and probably many other OSs are extremely expensive, which is why it actually reduces performance tremendously. So since MySQL 5.6 and MariaDB 5.3 onwards, there is what is known as group commit in the binary log. So when you turn on the bin log and you turn on sync bin log equals 1, InnoDB flush log at transaction commit equals 1, you actually don't see adverse effects, because now there's an algorithm that will actually just commit 3 or more parallel running queries inside as one fsync call, as opposed to making 3 fsync calls or 10 fsync calls. So again, I think the most important thing here is to also use modern database software. Storage. There's plenty of storage available today. SAS disks are pretty common. Now, if you happen to be using a spinning disk, the benefits for this may be for streaming data. There are some engines like ScaleDB that can benefit from you using large quantities of disk. You may also happen to have some form of storage that is either via NAS or using something like DRBD. NASs bring in the problems of having things like latency. You have locking, syncing issues, so you definitely want to test your reliability. Overall, SSDs I would definitely come back to later, because I will have a slide dedicated to that. And then and this is also true for things like Fusion IO and NVMFS or NVMe based devices. Generally, when you're measuring I/O, you want to look at your performance numbers around I/O, and sometimes you may see very good average performance, but extremely lousy variance. So measure with granularity. You don't want to be having spikes that go down, up, down, because average performance may be good, but the more granular you look at it, you may actually be seeing that you're just doing nothing at points in time. And generally speaking, when it comes to I/O and storage efficiency, you want to make sure you're also having a lot less write amplification to ensure your storage will last a lot longer than you expect. I mean, people buy hardware thinking they're going to last maybe 3 years, but if you can guarantee 5 years of uptime, that's actually extremely good. And of course, storage is also important from a space amplification perspective, because you want to use less storage. And more backend storage engines today have compression, right? So InnoDB has compression, TalkDB has compression. If you happen to be using RocksDB, that also has compression. So you should be thinking about compression a lot, especially when you're buying more expensive SSD or NVMe-based devices. When it comes to schedulers, or I/O elevators as they can be called, you have things like the CF queue, which is a per process queue, where each process will get a fixed time slice based on the priority of the process. It is generally the default that ships. It's generally good for storage like SATA-based disks. So again, you may use this when you end up using something like ScaleDB, which is targeted at time series data. There is also the no-op, which is aimed typically for SSD storage. First in, first out. Then there's deadline, which is something most database servers installs tend to end up using, because this gives you 2 queues per device. So you have one queue for reading and 1 queue for writing, and the I/O is dispatched generally based on time spent inside of a query. Depending on what kind of Linux you're using, there may be an anticipatory scheduler, which I believe has been removed down the line as well. You probably want to forget that even exists. Generally, you want to test and benchmark based on your workloads. You obviously want to buy the best quality hardware you can afford, so good quality RAID controller. And obviously, battery back makes a lot of sense here. So again, if you use something like Ktoon and TuneD, it has profiles that will actually turn it on, failing which you can just turn it on by doing at boot time elevator equals deadline. You can also turn it on via just echo. And generally, why we say deadline, at least in the MySQL world, we see that CFQ will serialize write operations, whereas deadline or even no-op will continue to scale with growing workloads. So the more threads you have, it actually continues scaling. And the MySQL model has always been 1 thread per connection. So yes, we do have things like a thread pool nowadays, but you still open up many, many threads, and you will have many, many connections in production, presumably. So a simple elevator benchmark where the first one had InnoDB flush log at transaction commit equals 0. And this is when we used MySQL without group commit, so it was done against a MySQL 5.5 instance. And obviously this has improved tremendously now in the sense that you should see 0 difference when you're using the deadline with or without transaction commit equals 0. But you will actually notice that there's a huge difference between the first and the third. So deadline for all intents and purposes is exactly what you're after today. And this was done with 8 disks, 16 gigs of RAM, and 8 cores, so fairly oldish machine. When it comes to file systems, you probably want to choose something like ext4 or XFS. They're very safe bets, and they have many other people using these file systems at scale. One file system you definitely don't want to use is HFS+. If you happen to have lots of money and buy Mac servers or Mac minis, HFS+ is not right for most database workloads. There are obviously mount options that you may think about using. And it's important to remember that I/O barriers are used to basically make sure that the journal will write to is actually written to the file system. So the advantage of this is naturally that your data is safe, but then you'll think about the fact that you don't actually end up using caches from that as well. So quick benchmarks, when you do a very large dump of nearly 2 million SQL rows with barriers enabled, you'll see something like 527 seconds for that. But if you turn off barriers, so you mount with the no barrier option, you'll actually notice this takes something like 21 seconds. So you can actually test this yourself as well. And when you look at InnoDB's flushing rate, you'll see that it can vary from something like 80 megabytes per second instead of 4 megabytes per second. So just having the barrier and the no barrier option in your test can be quite useful for this sort of purpose. You can keep your data and indexes on a single volume, but if you think that separating things makes sense, you can separate your binary logs as well as your data files if you want to. And this is especially useful in case you end up losing a disk. But generally speaking, I would just keep the data and indexes on a single volume. And this is probably important also if you end up using TalkyDB, which actually creates many files inside of a directory, as opposed to InnoDB, where now the default is 1 file per table. Definitely, you should know all your mount options. Mount options change over time as well. ZFS is another cool file system that is just started shipping in Ubuntu maybe last week. It's very familiar for the BSD folk. In fact, there are even tools around the Postgres world that depend on ZFS. We don't see many people using ZFS in production besides the BSD folk because it's for the longest time we're not sure how legal it is to be in the Linux world. But like I said, the Postgres tools, they can benefit from it. You can use ZFS snapshots, so MyLVM backup will actually also generally be able to create ZFS snapshots for you. But in Linux, we've yet to really see much production use of this. And it's probably also worth mentioning ButterFS is another fairly interesting file system, kind of based on ZFS. But again, we don't see many people actually running this in production. We know people having test workloads, but definitely not production workloads. So if you're going to play with more modern file systems that are not ext4 or XFS, maybe you'll take good backups that you can restore. Yeah, and of course you can use iostat to measure the I/O operations on your file system. Now, when it comes to SSD and Flash, you'll actually realize that the older hardware RAID controllers were more or less optimized to reduce random I/O, and you generally don't expect disks that support so many IOPS. But today, you obviously have much better RAID controllers, so running something modern also makes sense. SSDs obviously give you very low latency. And Flash is getting a lot more popular, right? I mean, you're getting a lot more IOPS than SSD. It's got a lot less latency compared to SSD. I mean, I think even if you buy a Mac laptop today, you're basically getting Flash as opposed to SSD. Now, the Flash obviously varies in quantity and in type of quality of Flash, so it's well worth taking a look at the type of Flash you're getting. Fusion I/O probably brought the first generation of Flash devices that you would buy for server use, but now you can get plenty of them from the NVM Express. Non-volatile memory is basically what Flash is. Fusion I/O, actually, we've done work with them, and modern versions of MySQL, MariaDB, as well as Percona server actually allow you to disable the InnoDB double write buffer. I mean, the double write buffer works as advertised. It basically writes twice. But this obviously increases the amplification in terms of writes. But if you use Fusion I/O, because it has this DirectFS capability, it allows you to just write once. So you can disable the double write buffer. So we will detect it upon startup and disable the double write buffer. But this also means that you have to be running what is known as DirectFS, a Fusion I/O based file system, which presumably nobody here is running. Does anybody run DirectFS? No. Does anybody have Fusion I/O devices? Okay, and you're running XFS on them? Okay. Yeah, so more or less people are buying Fusion I/O devices, but they're definitely not running DirectFS because nobody likes running beta file systems, I'm guessing, in production. When it comes to using things like SSDs and Flash, as I mentioned earlier as well, you'll now start thinking quite heavily about compression also. One thing worth mentioning is that the double write buffer obviously writes twice, but Percona, in their release of MySQL 5.7, has introduced something new as well. So if you end up using Percona server, you'll see that there's something known as a parallel double write buffer, where you actually get a private buffer pool for each and every instance. So the regular double write buffer is shared between all the buffer pool instances and all the Flusher threads inside of InnoDB. But having something private will actually possibly boost performance for you. And this is currently only available in Percona Server 5.7 from maybe 2 or 3 months ago. So it's still relatively new. It's not made its way into any other MySQL or MariaDB yet. Yeah, so always remember to look at the size of page, divide that by the size of row, and you'll have a fairly good understanding of what the write back of the page would be when it comes to even modifying rows. And this is again where you may want to then change your page sizes for InnoDB. Up here, I did not include RAID 6 or RAID 50. And generally speaking, you probably will end up having RAIDs for your database server because you care for the data underneath it. And this is obviously true for MySQL. This is also probably true very much for Postgres. But it is definitely not true if you end up having to run HDFS or Hadoop. We always say RAID your database servers, but you don't do that for Hadoop because the nodes should never ever run as RAID. Hadoop itself actually orchestrates data redundancy across all of its nodes. So the only nodes that should actually end up having RAID may be Hadoop's master nodes, but never any of its other nodes. So the whole advice of RAIDing your database servers that you will see commonly on the internet will probably not apply on Hadoop workloads. And this is generally true for a lot of bits and pieces of advice you end up finding on the internet, because sometimes it works for one person and it may not work for you, or it may not work for most people, but they have really good Google juice. So, do people here use LVM? Okay. So LVM is great because obviously not only do you easily expand your disk by adding more physical disks, you also end up getting snapshot backups, which is extremely useful in the MySQL world. Though generally now you're wondering, why do you really need snapshot backups? You can already do logical backups with MySQL dump. You can do physical backups with extra backup. But maybe you're using engines that don't use either of this, and then you'll end up using LVM. But there are obviously snapshot penalties with LVM. Each extra LVM snapshot will give you a 2 to 3% performance write penalty. But your first snapshot, depending on the way your data is structured, can give you up to a 40% loss in performance penalty. This is actually pretty huge. And a good way to test this is to go and try RDS. You can fire up one RDS, and you can fire up one RDS multi-AZ. Or you can do this in EC2, basically, yourself. And you'll actually see snapshot penalties are actually quite high. Hadoop, again, does not recommend that you use LVM because it has latency, and it really is a bottleneck. TalkUDB, this used to be the best way to back up TalkUDB because, hey, you didn't have an enterprise backup tool that you wanted to pay for. But TalkU backup is now also open source, so again, maybe you don't need to use LVM. MongoDB, so a famous use case for this was for the parse team. They actually create consistent snapshots, and they use EBS snapshots for MongoDB. So it's worth noting that when you do an LVM snapshot, you will actually lock your MongoDB instance. So if you use LVM on top of something like EBS, you may end up realizing that you can do things like pre-warming after a snapshot has happened. So always remember that LVM is useful, but it doesn't come for free. So think about snapshot penalties. Measure your snapshot penalties. Now, when it comes to memory, I'm sure many of you use modern servers that are NUMA capable. Generally, you should have at least the next 5 minutes of your working set sitting inside of memory. And NUMA is where memory is addressed on a per CPU basis, so your local operations on a CPU will obviously cause lots of swapping, even if the memory is available. NUMA interleaving is something that Oracle, the database, actually has, but for a very long time, MySQL and MongoDB didn't have. So when you run today MySQL on a fairly large system, where fairly large is maybe you have 64 gigs of RAM, which is maybe not so large to you now, you may want to obviously have NUMA control interleave equals all, and then start up MySQLD. This is especially true when you let's again say you have 64 gigabytes of RAM and you have a fairly large InnoDB buffer pool, maybe 48 gigabytes. Over time, Linux will actually decide to swap out large amounts of your memory and appear that it's under memory pressure despite actually having no memory pressure. In Postgres, they have a solution for this. It's called the zone reclaim mode. Postgres actually allows you can actually just set VM zone reclaim mode equals 0, and Postgres will continue working as well. But in the MySQL world, this is what you're looking for. And to be fair, Percona Server 5.6 onwards, as well as MariaDB 10.1 onwards, actually has functionality to control your servers when you're using NUMA, so that you don't actually end up having swap insanity, so to speak. And this is important because you're getting a modern server, and then you're finding out that it doesn't perform as well as maybe an old server. MySQL, for example, uses memory for things like session buffers. It uses things for statistics inside of metadata, locking stats as well. And if you use things like the user stats, it actually counts index stats, user stats, client stats, and so forth. Obviously, MySQL also uses it to cache data. When it comes to where else is memory used, you'll find that with regards to MySQL, you have obviously got the idea of having a binary and relay log, so memory gets used there. MySQL, MyISAM, if you are still using it for whatever reason, will actually completely rely on the file system cache. So it uses DOS as opposed to creating its own buffer pool. If you use Postgres, it has the concept of having a write-ahead log. And wells are getting more and more common even in the MySQL world, especially if you start using something like MyRox and RoxDB. They also have the concept of a write-ahead log. And of course, you can do something like free-m to find out how much memory you actually really have. Show engine InnoDB status is obviously going away in the future, so you will now have to make use of what is known as the performance schema inside of MySQL 5.7 and going forward. Performance schema also does not come for free. All of that instrumentation actually will give you some actual use of loss in performance, and this can be anywhere between 3, 5, 7%. It's been measured differently by different folk. So again, you definitely want to look at that. Transparent huge pages. So if you have an app, like a database, that has a lot of memory access, and you may actually realize you can obtain improvements by using very large pages because you actually reduce the looking inside the TLB, the translation look-aside buffer, and you'll actually access more of this data inside your buffer pool. Solaris, for example, has extremely large pages, 256 megs, if I'm not mistaken. But on Linux, this more or less means that you end up handing anywhere between 2 megs or 1 gigabyte of a page on a malloc. And people set huge pages via VM and are huge pages. MySQL generally may benefit from huge pages, but MongoDB doesn't. Neither does Redis. Now, I would personally turn off transparent huge pages because if you're on, even BSD, this is not something you're good at doing. And if you use an engine like TokuDB or even TokuKV, memory tracking actually does not work, which will actually lead to overcommit. And why does this happen? Because they don't use the standard malloc library that you are familiar with. They use JE-malloc. And JE-malloc calls up madvise instead of just regular malloc. So the implementation of dealing with memory fragmentation inside of JE-malloc will actually mean that you need to turn off transparent huge pages. Now this brings up a very interesting difference when it comes to using something like MariaDB, a modern Percona server that ships with TokuDB, and MySQL. Because if you're running just stock Oracle MySQL, you can actually have transparent huge pages on. But if you're running MariaDB or a modern Percona server, you'll actually have to turn this off because of the TokuDB engine that is included inside of these servers. JE-malloc will also bring other fun issues, like it makes it extremely hard to work on FreeBSD. And there are open bugs to fix this. It's more the malloc library that needs to be ported. Now, when it comes to Swappiness, the internet is all for saying turn off swap when you have a database server. That's all fine and dandy, except that in most modern Linuxes, this will also mean that the out-of-memory killer will come and it will kill your database server. Then you'll have to start it up again, and all your buffers will be cold. So VM Swappiness equals 0 actually will call the OOM killer, and it turns out it was a bug in the kernel. So if you actually happen to run InnoDB flush log a transaction commit equals 0, because you thought that it would give you better performance, you would actually lose uncommitted transactions or transactions that were not committed to the log yet. And this is extremely bad. So basically, to get the old method of VM Swappiness equals 0 back again, the new way to do it is to say VM Swappiness equals 1. The default, if I'm not mistaken, is set to 60. So basically, if you have a modern kernel, version 3.5, or thanks to RHEL, they backported it also to a 2.6 kernel, you definitely want to make sure that you have VM Swappiness equals 1 to ensure that you get the minimum amount of swapping without disabling it entirely. This is extremely important, otherwise you will have servers, you will have MySQLD that just disappears, and you will be extremely unhappy. Especially if you're running with a 48 gigabyte buffer pool and it just went to 0. Warming that up could take quite some time. Though now there are multiple tricks that you can use via, say, intra-schema parallel replication in 5.7 or even MariaDB 10.0. For when it comes to CPUs, you can definitely set it to performance, and if you use tuned admin, it'll actually set it to performance by default. You probably want to disable power save mode because you're not running this on a laptop. You need to install CPU frick utils, which is not necessarily part of the distribution installed by default. And you definitely want to configure your BIOS, and BIOSes are changing. Nowadays, you also have all these graphical BIOSes, so make sure you ensure that you hand over power control to the OS. When we're doing lots of testing, especially when it comes to Galera cluster or application, we end up using a lot of TC because you can actually show as well as change traffic control settings. This is a great tool from a benchmarking standpoint. You definitely can also use dropwatch, which is a kernel drop packet monitor. you can afford the best Ethernet, so use the best, so you get more bandwidth. Trunking and bonding is also still something you can still do for HA. And something that you may want to turn on by not saving TCP metrics is that, by default, TCP itself will save various connection metrics in the route cache when the connection closes. So if you turn this off, you may actually see some performance improvement. So you don't actually cache anything when the connections are closed. And this generally saves probably the last 1,000 or so connections, give or take. You probably want to have the ARP filter, especially when you're using something like, again, Galera. Because a database server usually has 2 network interface cards, so if your queries are loaded on your private LAN, you never ever want the traffic to accidentally go through the public LAN, so you turn on the ARP filter. The idea for having jumbo frames makes sense when you're using things like Cassandra, Hbase, NDB cluster. If you happen to use DRBD for the RAID over Ethernet to ensure you have an extra copy of your data on a passive master, turning on jumbo frames actually makes sense. We don't see a huge benefit for OLTP workloads, but we definitely see benefit for data warehousing workloads. So if you happen to use InfiniDB, InfoBright as well, again, jumbo frames actually tend to work quite well for you, or the new MariaDB column store. There are a few other things you may end up wanting to tune, like increasing the kernel packet buffer, reducing TCP timeouts when connections have closed. TCP fin timeout basically will determine how long to wait for a fin. Defaults are not necessarily as sensible when it comes to servers, so you probably want to change them. If you happen to be running Galera cluster, it is always worth noting that Galera will write as fast as your fastest node, as fast as your slowest node. So if you happen to have 2 very good machines, and then you have this laptop as your 3rd node, writes are going to be as fast as this laptop. And then you also need to tune the EVS protocol, which is there for auto eviction purposes of getting rid of members of the cluster. And you need to tune the send windows and the user send windows to something large. By default, this is actually not tuned as well. If you obviously run Galera, you can route the GCOM traffic, because Galera doesn't only require you to have port 3306 open, it also requires you to have a GCOM node open, GCOM port, and you can route all GCOM traffic, so that's the Galera cluster communication traffic, to a second network interface card, so you actually keep your main network interface card for your transactions. I thought I'd include this here, largely because I was chatting on IRC a couple of days ago, and a guy was like, hey, I can't get any core dumps. Okay, well, it's because you didn't set your resource limits. But that's more important than just getting core dumps, is that if you end up having to use something like MongoDB, MongoDB, for example, requires 1 file descriptor for each data file in use, as well as 1 file descriptor for each journal file in use when the journal is being used. And when you have replica sets, which is again one of MongoDB's claims to fame, you have to remember that each and every MongoDB instance will maintain a connection to all the other members of the set. So a default resource limits are extremely low for MongoDB to actually just get working at scale. So you definitely want to turn this up. And of course, when MySQL crashes, it's nice to get those core dumps. You definitely want to also tune your database. I mean, tuning Linux is all fun, but you also need to find all those slow and crappy queries. So in the MySQL world, there's PT query digest that will parse the slow query log. In the MongoDB world, there's PT query digest -mongo that will parse the slow query log. You obviously want to monitor things like errors that are sent back to the client. So MariaDB ships a plugin that will actually log all of these errors, and you'll actually be able to look at them to see if there are things that you can improve. And of course, you want to configure your database. It turns out that when you install a database, the my.cnf is for the base config, right? The base config assumes that you have 512 megs of RAM, so you can start this up in a cloud instance. Imagine having the base config that actually sucks. Virtualization is extremely popular today. I'm almost certain even if you're running on bare metal, you may be using this. Databases, of course, run best on hardware. So one of the key things to remember is guests run as processes inside a user space on a host. So you basically get your virtual CPUs, but it's worth remembering that guests will inherit kernel features like huge pages and NUMA. So make sure you've turned off huge pages, for example, when you want to run Percona server MariaDB. Native AIO is used over threaded today, so that's native AIO is asynchronous IO. InnoDB use native AIO equals 1 is now the default. We have seen instances where the hypervisor actually lies that the virtual machine did an fsync, so you can actually lose data. These hypervisors tend to be more commercial variety hypervisors. The open source ones tend not to lie. On Linux hosts, if you happen to use VMware, it does not use unbuffered I/O. So, because it's not safe or supported across all Linux versions that VMware supports. So basically, VMware's hosted products on Linux will always use buffered I/O. Now, how many people here use VMware for virtualization? Wow, that's quite a lot of you. So VMware actually, besides what I just mentioned, they actually have fairly lengthy documentation on how they differ from what you may be familiar with, like Xen or KVM. Containers are getting extremely popular as well. Kubernetes. So you can today go to vitess.io and roll out without any issue Kubernetes with Docker and MySQL instances or MariaDB instances and have it running in Google's cloud. The only issue here is you obviously have to give them your credit card number. But it's actually made it extremely easy. So a good example of what Vitess can do is it can actually do sharding for you. And that's how, for example, YouTube itself maintains sharding. Because every time you make one connection to MySQL, it can use anywhere between maybe 256 kilobytes of RAM to up to 3 megabytes of RAM for that connection. Whereas Vitess actually reduces that cost of the connection to down to 32 kilobyte BSON blobs. Besides that, I would definitely do some benchmarking yourself to actually realize what kind of performance losses you're actually seeing. We've seen, obviously, some overhead and performance loss, and we see less for read-only workloads. And I guess containers like Docker are great for you to be trying things out on your dev machine, but maybe it's not quite there yet for production. EC2, for one, has instance limitations. If you happen to use hosted versions like RDS, you want to also watch your costs. It's worth noting that MySQL and MariaDB on EC2 are cheaper than Postgres on RDS, are cheaper than Postgres on RDS. I don't know why it costs more to host Postgres, but you pay a Postgres penalty to run it on RDS. Get it maintained and managed by Amazon. We see, with regards to EBS, a lot of unpredictable I/O performance. So if you are running a database node, either use RAID 10, RAID 0, or pay for provisioned IOPS. We find that as people grow, they give up RDS and they switch to using regular EC2 where you can now install whatever you feel like it on that and have a DBA maintain it. Today, RDS, of course, now gives you a MySQL 5.7, 5.6, 5.5. It also gives you MariaDB Server 10, but not 10.1 or Postgres. But you may want to run Percona Server or some modern version of MariaDB 10.1, for example, and none of this is available in RDS. When you are loading data, if it's a Postgres instance on RDS, you definitely want to turn off backup retention. Also, when you're loading data to RDS, disable multiple AZs. This can be for all databases, because you don't want to be writing to a passive master somewhere. You might as well get the full performance of actually loading the data. Don't disable fsync. Really. Don't even disable InnoDB flash log and transaction commit, especially when you're running on hardware you do not control. There are obviously some interesting reasons as to why you may want to run MariaDB or Percona server instead of stock MySQL. For one, there's a thread pool. And since we're here talking about performance and tuning, a thread, as I mentioned earlier, MySQL has a one thread per connection model. If you have many cheap, short-running connections, this actually opens up threads. It actually ends up using up memory. Have a thread pool that you can actually just pool the threads together and constantly reuse those connections. And the thread pool works natively on all Linux distributions, BSD, as well as Windows, actually. So the thread pool is available in MySQL, but it's only available in an enterprise release of MySQL. But I'm sure we're all here for open source. So again, MariaDB and Percona server have that. NUMA interleaving is extremely important when you have large amounts of memory, so that's probably another good thing. Having faster InnoDB restarts, a parallel double write buffer, and in earlier versions, ExtraDB also had the idea of InnoDB fake changes. So if you happen to have a crash and you need to start up, you could just run fake changes to do all the DDL operations and then roll them back. So you'll actually just warm up your buffer pool. And that's actually pretty useful. And of course, the new parallel double write buffer is something that could be also quite interesting to look at. And of course, you can run something like Galera cluster as well. You don't only have to run, MySQL or wait for group replication and so forth. When it comes to data center stuff, we've seen bad batches of network cards, bad batches of disk. I'm sure you've seen just bad batches of stuff in general. So, and you may find that bad batches actually cause random bugs that show up as well. So, well worth checking to make sure that it's not your hardware that sucks. There's actually a problem. When you run Hadoop or Hbase on EC2, this really is a network abuse alert, so we obviously don't recommend you to do that. You also want to make sure things like name resolution always work in your network. You want to have bonding. But beyond that, the major thing you want to change when you're running Hadoop, Hbase, or even Cassandra is to basically increase your U-limits and also know that you don't want to really run this in the cloud, generally speaking. It's extremely, extremely noisy on the network. Many other databases also give you tuning manuals. And things like Neo4j, which basically just says, again, just change the U-limits. There's really nothing else that you need to do to get going. REAC has generally very similar tuning when it comes to the network, so pretty much what I talked about earlier will generally work for REAC. They recommend in their docs to disable swap, but as I've already said, you definitely don't want to disable swap. At least set it to 1. The mount options in the REAC world, again, are extremely similar to what you do in MySQL. And they do specifically state that they would benefit from a deadline scheduler. MySQL doesn't really state what you'll benefit from. It's actually okay with you using whatever. But obviously people benchmark to actually realize that it's better to use deadline. I hear a lot of people love to say that they should just disable SELinux. You really don't want to do that. If you find SELinux extremely hard to understand, Red Hat even made this nice coloring book to help you understand SELinux. They've made it accessible. In fact, when we ship MariaDB, we ensure that it works with SELinux. We have seen people complain, at least on the forums a while back, that AppArmor on Ubuntu will actually cause systemd issues on MariaDB server. Basically, AppArmor will come in to kill the MariaDB server. This usually happens because someone decided to compile their own software and then package it up themselves, at which point they should also learn to package up AppArmor stuff. We ship everything in a way that should generally just work for you. And we also ship inside the Linux distributions. So naturally, we test against things like SELinux and AppArmor to make sure that they work. So if you happen to want to compile stuff yourself, you should definitely fix it. There are plenty of tools that you probably are familiar with. I have not even put up there something like Poor Man's Profiler, which basically ends up making use of things like GDB. There are obviously many MySQL-only related tools that are quite handy. I would say the Percona toolkit has a lot of them that could be useful. Many of those tools have been sort of vaguely ported to work on the Mongo world by independent members of the community. GDB, surprisingly enough, is extremely useful. It's also an extremely useful tool when you want to switch options in, say, a running MySQLD without restarting a server. I won't bore you with those details or encourage such behavior, but I'm sure if you search the internet, you will find some good information about that. When it comes to benchmarking, there are plenty of benchmark tools that we end up always using. Sysbench. Sysbench is not just useful for benchmarking MySQL, it's also useful for benchmarking your systems in general, so to speak. You can benchmark like file IO as well. You can also use something like Bonnie++ for that, but you can compare the Bonnie++ and Sysbench results. Linkbench has a more realistic social networking workload. No surprise, it comes from Facebook. So it works not only for MySQL, but also for MongoDB. If you happen to use the other NoSQL big data stores, the Yahoo Cloud Serving Benchmark is actually quite good as well. Something you may want to take a look at. And if you wanted to compare what clouds look like, Google's PerfKit benchmarker will allow you to, once you have accounts with, say, Azure and Google and Amazon and so forth, will allow you to compare the performance that you tend to get from the instances that you're getting on these platforms. And it's true, Google's performance, I mean, if you measure hosted MySQL on, I've done this for Amazon, Rackspace, as well as Google. Google's hardware and provisioning time and so forth is extremely the best. One wonders what they have behind there, and I think maybe in 2012 they released some information about what the hardware was like then. I can only imagine what it is like now. There are also plenty of fairly good books that one might want to read. High Performance MySQL, while it doesn't cover MySQL 5.6 and 5.7, so some of the premises there which state MySQL shortcomings may have already been fixed, and 5.6 and 5.7 really has fixed quite a lot of that. The other one is Systems Performance Tuning, that's also extremely good. I personally enjoy many of Brendan Gregg's talks because they go extremely in-depth. They also allow you to look at things like dtrace and so forth. Most likely your vendor also provides many of these tuning guides that you can end up using. Again, if you look at Red Hat or CentOS, you don't end up having to read these guides because most of them just say, look, use tuned, and it generally just works. My slides don't have any branding, so hi from MariaDB Corporation. And with that, I think we're 54 minutes into this. I'm open to answer your questions, and I will repeat the questions for the video. Does anybody have a question? My old colleague has a question.
Yes, hi Colin. Is it on? I hope so. When discussing file systems, I missed a remark about XFS dynamic pre-allocation size. In my opinion, it's extremely important to have that under control, because otherwise you will waste lots of disk space and not get it back until you stop your MySQL instance. Or any other database the same.
Yep. XFS dynamic pre-allocation size, and this was actually more a problem with earlier versions of XFS rather than current versions of XFS. I don't see this as a huge issue with XFS that you get in CentOS 7, but are you seeing differently?
We have seen issues with it, and I've blocked that you should set a mount option to avoid that.
Fair enough. So we should refer to Jorg's blog. Or is it the...
It's available via Planet MySQL.
Okay. Yep, okay. And question?
Yeah, can you tell us your thoughts about, you talked about KVM virtualization. Typically you will have LVM storage layer in KVM for VM storage, and then you can have your XFS or XT4 VM file system. Do you have any thoughts about how this would impact performance, like when you run LVM snapshots on the KVM host, or maybe the network storage or whatever? How does that impact the VM if you run a database in the VM?
Yep, so the question is, if you run the database in the VM and you also obviously have LVM inside there, and you also have a file system, naturally either XFS or ext4, what is the performance impact? The performance impact inside the KVM is also very similar to the disk level snapshots that you'll do on bare metal. So the first snapshot is extremely expensive. And I said we see 40%, but we've also seen worst case first snapshots be much higher than that. And that's the first snapshot. But every other following snapshot is actually not so bad. So again, it has no effect if you happen to be running it inside of a virtualization platform. But of course, if you end up giving it extremely small amounts of memory, you may see memory pressure, and then you'll actually get much worse performance as well. But that would be the same if you happen to run it on bare metal with very little memory as well. But yeah, LVM snapshots are today probably not the best way to get a MySQL backup, because dump can give you a logical backup, extra backup can give you physical backup, and hot backup for Tokyo backup can also do something similar. So there really isn't much need for you to end up having to use LVM snapshots. I think LVM snapshots were a very good solution for maybe the last, maybe 5 years ago. Or actually even longer. I think MyLVM backup is a tool that started in maybe the early 2000s or mid 2000s. Okay then, thank you for listening.